All right, hello, my wonderful students. This is part one, or the first foldable, I should say, the first foldable, chapter 8.2 and 8.3, circles using theta, alpha, and beta. So we did this already in class, but I kind of wanted to go over it just for the students that were absent and make sure you guys have a good understanding of what's going on. Let me zoom in a little bit here. All right, so first things first. Like I said, we're going to do the same thing that we did when we were doing the human experiment, when you guys were kind of like moving your arms to meet theta, you know, to find the theta, beta, and the alpha. So we're going to go ahead and start with our first one here, which is this one. So we have our theta, and theta we're going to use in this blue color. So to try to match what we were doing in class. So pi over 6, I know pi over 6 is 30 degrees, but we'll do that after. So I know it's about right there. So this is going to be our theta equals pi over 6. And then we have to find our alpha now. So our alpha was in green. So we know our alpha is the angle that's closest to the x. So if we see this is the x-axis here, let me write it in a different color. I don't want to confuse you with the alphas. So the theta is actually here. If our theta was on this side, then it would be here. But if our theta was on this side, it would be here. It doesn't matter where the theta is, but whatever the closest x-axis is to theta is what the alpha is going to be. And alpha is always going to be positive regardless of whatever it is. So just like theta being pi over 6, because it's the same, our alpha is also going to be pi over 6. Because that's what the degrees of this is here. All right, so in order to find our beta, which is our coterminal angle, it has to finish. Coterminal means it's going to finish in the same spot as the theta. But we can't just do the same operation. We got to do something different. So the easiest way to do it is to just go the negative or the opposite version of what this is going. So if theta is going positive, I like to just take beta and then go around to the negative side until I stop here. And I'm going to put a little dotted line here so you see that the beta is actually there. So it doesn't completely cover the theta, but you'll see it's there. And then we have to try to figure out what's the distance from here all the way around to here. Well, I know this is in sixth because it's pi over 6. So I can count from here to here is 1 total. So this would be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. So this is actually our beta is actually going to be negative 11 pi over 6. 11 pi over 6. So that's because we went around 11, and then this one would complete 12, which would give us our 2 pi, which is all the way around the circle all the way around the circle one time. All right, so now we have all these wonderful things, but now we got to actually convert each one. And I'm just going to do theta up here because I don't have that much space down there, to radians. They're in radians. We got to convert each one to degrees. So we're going to go ahead and do our theta first, since the first one we did. So if you guys remember, whenever you have your what you're looking for, you need to multiply it. Whenever you're trying to get the degrees, is going to be equal to our radians, which in this case is pi over 6, times our 180 over pi. Move that a little bit. Sorry. Our radius times 180 over pi. All right, so our first one here, we have our theta, which is our pi over 6. We're going to multiply that by 180 divided by pi. So already we can see that we can reduce the pi's. Oop, my pen went out. Okay, I'll just use pencil. So we can reduce the pi's, and we're left with 180 divided by 6. Well, I know 18 divided by 6 is 3, and if I add the 0, that gives me 30. But I'll just rewrite that over here again for you. So I have 180 divided by 6. And once again, it's 18 divided by 6 is 3. Add the 0 is 30. But we already know this was 30 degrees because I had said that in the beginning of the video. So this is 30 degrees here. And we know our alpha is also going to be 30 degrees because our alpha is the same. It's also pi over 6, 30 degrees. And then our beta. Our beta is going to be similar, but we're going to have negative 11 pi over 6 times 180 over pi. So similar story, we have this divides this, and we're left with this here. But if you see this is familiar. We have 180 divided by 6. Same thing as 180 divided by 6. The only thing different here is that we have the negative 11. So this is still going to give us 30 degrees, but then we're going to have to multiply by 11. So we're going to have negative 11 times our 30 degrees, and this is going to give us our negative 330 degrees. So that's what's going to go here, negative 330 degrees. All right, let's move on to our next one. Next one's very similar. We have our theta, which is now 4 pi over 3, and we have our xy. So same as before, we're going to have our x here, just so we can relate it to our alpha later. And we're going to go ahead and graph our theta. So I know it's in thirds, and this is bigger, so I know it's going to go all the way, at least halfway around and a little bit more, because to go 3 over 3 would give us just pi, which goes here. So I want to make sure we get that. So we're going to go ahead and go around. So we're going to count 1, 2, 3, and then the last one is 4. So our theta is going to be here, and theta is equal to 4 pi over 3. Put that all over that. So now this is going to be a little different because our alpha, remember I said our alpha is where the theta is the closest x-axis. So this is actually here. So I knew this was in thirds. It was 1, 2, 3, 4th. So I know this has to be, so our theta, our alpha has to be pi over 3. Because it was 1 pi over 3, 2 pi over 3, 3 pi over 3. In order to get from 3 to 4, you just had to add 1 more pi over 3. Okay? So that's how we got our alpha. Alright, so now our beta, like I said in the last video, in the last one, I said the easiest way to do it is just to go the opposite direction. We see this is going positive to 4 pi over 3. So we're going to go the negative route this way and stop here. We're also going to dot this line to show you guys that I'm actually there. And now, so we got to count. So we know it's 2 pi all the way around, and it's at 4 pi over 3, but still in thirds. In order to go all the way around once, it's 6 pi over 3. So I know that this is going to be 2 pi over 3 in order to get that way. So our beta is going to equal negative 2 pi over 3. So now we got to convert all of these to radians. And I kind of messed myself up a little bit because I squished everything together, and it's going to be hard to do our conversions, but we're going to go ahead and take care of it on top, at least for our theta. So we'll just do our theta here. Since it's already here, we're going to multiply it by 180 divided by pi. So we can already see that we can divide our pi's out. And then we have 180 divided by 3. Well, the same thing I could do before. I said 18 divided by 3 is 6. And then we add our 0, which makes it 60. So we can go ahead and do that. We have 4 times 60. Once again, I did 18 divided by 3. I can rewrite right here. So I did 4 times 180 divided by 3. I just did the association property of multiplication. It says I can switch them because I'm just multiplying and dividing, so I can do that. If I was adding or subtracting, I wouldn't be able to do that. But multiplying and dividing, it's okay. So we just switch these two numbers. So instead of that, we have 180 over 3 times 4. This gives us 60 times 4. So once again, I can go ahead and cover my 0, and I see that 4 times 6 is 24, plus the 0 would be 240. So our theta is also 240 degrees. Well, that makes it easy to find our alpha, because if this completes a full circle, which is 360 degrees, I can actually subtract 360 by this and get what our beta is. But I'm not going to do that. I'm actually going to do the work for it here. So we're going to do our, we're going to do our beta. So we have our negative 2 pi over 3 times our 180 over pi. And as you can see, once again, we have a very similar situation, except we don't, instead of the 4, we have a negative 2. So this is pretty much the same. So we're just going to go ahead and divide our pi's again. Then we're going to say this ends up being 60, because it does. If you notice here, this was 60. So it's going to be 180 divided by 3. It was not negative, I just marked it. is going to be 60 degrees times negative 2. So it's going to be negative 2 times 60. So our beta degrees is actually going to be negative 120 degrees. So I'm going to box this off so I don't get confused. And then last but not least, we have our wonderful, wonderful alpha, which is here. And that's going to be very similar to what we have over there. We actually have our pi over 3 times 180 over pi. But once again, that's the same thing that we have here without the 4. So we already worked this out, and we showed that these divide, and then 180 divided by 3 is actually 60. So this is actually going to be 60 degrees. And we'll go ahead and box this one off as well. Okay, and that's the first part.